Imagine this. You wake up one morning and you're the CEO of the third largest company in the world. Just last week, you posted another record quarter, which resulted in a one-day gain of the same size of an entire Netflix. You have the most cutting-edge chips, the best AI researchers, and a cash stockpile the size of many countries. Jensen, the CEO of NVIDIA, is in this exact position, and what he decided to do is go all in on AGI. But not just AGI. He's building a superstar team to achieve AGI in any modality and any reality. And the entire team is built around one man, Dr. Jim Fan. He's simply starting a team dedicated to extending his research around the foundation agent. Everything has been leading to this, and that's what we're going to be talking about today. We're going to briefly go through all of his incredible contributions that led him to starting a team that is well positioned to achieve AGI. The best minds, unlimited cash, and the largest collection of GPUs in the world. Let me show you why this is going to change everything. And Andrew Karpathy left OpenAI. Gemini 1.5 has essentially unlimited context size. Chat with RTX was released by NVIDIA. And Groq stunned everybody with their inference speeds. Let's take a look at all of it. So first, Dr. Jim Fan, who, if you're not familiar, Dr. Jim Fan is a head researcher at NVIDIA, a very, very important person in the world of AI, and the work he's doing on something called Foundation Agent is truly mind-blowing. And now he's going all in on Foundation Agent. So here he says, career update, I am co-founding a new research group called GEAR at NVIDIA. So he's not leaving NVIDIA, he's simply starting a new organization within the company. With my longtime friend and collaborator, Professor Yuk Zhu. GEAR stands for Generalist Embodied Agent Research. And this is exactly what he has been promising with the Foundation Agent. And I made an entire video about the Foundation Agent because it was truly futuristic and something that could change the face of artificial intelligence completely. And if you want to check out that video, I'll drop a link in the description below. We believe in a future where every machine that moves will be autonomous, and robots and simulated agents will be as ubiquitous as iPhones. We are building the Foundation Agent, a generally capable AI that learns to act skillfully in many worlds, virtual and real. And for a quick reminder, the first time we started hearing rumblings of the Foundation Agent was when they built a Minecraft agent that essentially could play Minecraft indefinitely and really reach the end game of Minecraft for the first time. And then in my previous video, I showed how they were applying that same architecture to operate in the real world fully autonomously. I am extremely excited about what Dr. Jim Fan is doing with his team. Now, I've made a couple videos about simulation, and this is an extension of that, because what the Foundation Agent promises to do is allow AI to operate in any reality. And so what does that actually mean? First of all, any virtual reality. So any video game it can operate within, no matter what the rules are, no matter what the physics definitions are, it can operate in any of those types of virtual environments. But then it can also operate in any real world environment. And it's doing that through the embodiment of a robot. And the way that they're training is by simulating a real world environment in a virtual environment. So all of a sudden, they have all of this amazing synthetic data that they can use to train a robot for the real world. Here he says 2024 is the year of robotics. And if you remember, that was one of my predictions for 2024. So I'm glad somebody who knows a million times more than me about the subject also agrees. The year of gaming AI, super excited about that. When we can interact with a game and all of the NPCs in the game are essentially alive and they change the game dependent on what I do in that world, that to me is a game I want to play. and the year of simulation. We are setting out on a moon landing mission, and getting there will spin off mountains and learnings and breakthroughs. Join us in the journey. So if you want to apply to their team, you can do so right here. So below that, he lists a couple highlights on some of the research that they've already been doing. So first, Eureka. GPT-4 writes reward functions to teach a 5-finger robot how to do pen spinning tricks better than I can, trained with GPU accelerated physics simulation at 1,000 times faster than real time. And that's what I've mentioned that is going to be applicable to real world robots. So they're training on GPU accelerated virtual worlds, and then they're going to be applying that to the real world. Voyager, and this is the Minecraft AI that I had mentioned. The first LLM powered agent that plays Minecraft proficiently. Voyager bootstraps its own capabilities as it explores the open-ended world continuously. And I made a video about this as well. I'll drop it in the description below. And here's Mind Dojo. Open framework that turns Minecraft into an AGI research playground. We collected hundreds of thousands of YouTube videos, wiki pages, and Reddit posts for training of Minecraft agents. And here's the Vima, the first multimodal LLM with a robot arm attached. We introduced multimodal prompting for robot learning. Now, I haven't covered this topic, but it looks really cool. And to dive a little bit deeper into this, it says, robotics will be the last moat we conquer in AI. What would a robot GPT's API look like? Introducing Vima, an LLM with a robot arm attached. It takes multimodal prompts, text, images, videos, or a mixture of them. You can say, rearrange the table to look like, and then you pass in an image, or follow the action, provide video frames. You can even teach it new visual concept in context. This is a WUG image, and this is a Blicket image. Now put the red WUG on the green Blicket. So these are nonsense words, but it kind of shows you what is possible when you're able to provide different modalities of input to a large language model. And it is open source, which is really nice. You can find the GitHub repo right here, and they have a paper as well. So very, very cool. Here he describes mimic play, solving complex robotic tasks by combining unstructured human play data and robotic teleoperation data. Now, I've made a few videos about teleoperation, and as a reminder, that just means that somebody is controlling the robot remotely, whether it's literally attached to the robot or doing it remotely through some kind of controller. But either way, that teleoperation gives the robot data to train itself on. So it takes that data and makes it more generally applicable to other actions that aren't exactly like that. And Mobile Aloha was a video that I made that kind of covers exactly that topic. They were able to train a robot that can move in the real world to do amazing tasks without explicitly defining how to accomplish those tasks using teleoperation to train it. And so Mimic Play is a library out of NVIDIA by Dr. Jim Fan. And to extend on Mimic Play, he has Mimic Gen. Robotics has a data problem, and actually all of AI has a data problem, and that's where synthetic data is going to come into play. Synthetic data seems to be the only way that we're going to reach AGI. We multiply high-quality human data by 1,000 times using digital twins in simulation. And he says right here, synthetic data will provide the next trillion tokens to fuel our hungry models. Now, there's actually a counterpoint to that argument. If we think about the human brain is able to learn incredible things at a fraction of the amount of information needed to train large language models. So if we're able to do that, why are large language models requiring so much data? That's something we're going to have to consider. It's possible that the entire Transformers architecture is just not the most optimal architecture to reach AGI. Now, this is the edge of my knowledge, so I'm not actually sure. I'm just posing the question to you. What do you think? Do you think because our brains are able to learn so much more with such little data that maybe we're not taking the right approach with large language models? Let me know in the comments. And here is Prismer, an open source multimodal LLM before GPT-4 was announced. It combines many pre-trained visual experts to be super sample and parameter efficient. And there's a bunch of projects that he's released from NVIDIA, and now he's forming an entire team to focus on this. So super excited for what Jim Fan is going to bring to the world. Really appreciate all the work you're doing. Next, a bit of AI news. Andre Karpathy has actually left OpenAI after just about a year being there. Let's see what he says. Hi everyone, yes, I left OpenAI yesterday. First of all, nothing happened, and it's not a result of any particular event, issue, or drama. But please keep the conspiracy theories coming, as they are highly entertaining. So he left. People sometimes leave jobs. That's fine. I'm really interested in what he's going to do next. Andre Karpathy is probably one of the leading AI minds in the world. And not only that, he's able to explain complex AI topics really simply. I'm very impressed with a lot of his videos that break down very difficult topics into digestible bits for people like me who aren't experts at this stuff. And I really hope he actually goes down the educational route, because he is one of the best educators out there. Actually, being at OpenAI over the last about year has been really great. The team is really strong, the people are wonderful, and the roadmap is very exciting. And I think we all have a lot to look forward to. My immediate plan is to work on my personal projects and see what happens. Those of you who followed me for a while may have a sense for what that might look like. So it's probably going to be education, but I don't know him personally, so maybe he has been working on projects that he's not talking about. So I'm definitely going to keep a close eye on what he does next. And speaking of Andre Karpathy, he actually made a tweet that led me to something that I found to be extremely cool. Here he tweets about a blog post written by Nicholas Carlini, in which Nicholas actually created an incredibly sophisticated benchmark to run against large language models. Now, you're all familiar with my benchmark, which is very unscientific, to say the least. But Nicholas actually created a GitHub repo with hundreds of tests to run against these models in all different languages. And not only are they well-documented tests, but they actually have a concrete output to check against. So nice post, but even more than the 100 tests specifically, the GitHub code looks excellent. Full-featured test evaluation framework, easy to extend with further tests and run against many LLMs. Now, what do you think? Should I adopt these tests? I like running my tests and kind of free-forming it and it being very unscientific, but maybe I should also adopt a more rigid framework for testing these large language models. Let me know in the comments what you think. And if we look at the test results, for the 100 current tests on 7 models, GPT-4 is still the best at 50%. GPT 3.5 is after that, Claude 2.1, all the way down to Mistral Medium, Mistral Small, and Gemini Pro last. So I'll check these tests out. Let me know if you want me to do a full video reviewing the test itself. But let's go into Nicholas Carlini's blog post. So he released a new benchmark, and some of the tests that he includes in his benchmark include convert a Python function to an equivalent but faster C function, explain the functionality of minified JavaScript, identify the encoding format of some data, write a parser, write some bash one-liners, and all of his tests are coding related. So maybe I'll use this LLM benchmark to test coding specific models. And I'm gonna get to another coding specific model that was just released in a minute. So here's some examples. We have print hello, the most basic. We have rewrite some code. We have some other tests. Here's a regex test, draw a triangle. So there's a bunch and they're all tested and output right here. I'll drop a link to this in the description below. All right, next let's talk about Gemini. I was on vacation last week, so I couldn't make a full video dedicated to Gemini, but Gemini 1.5 was released and a lot of people are saying great things about it. Now, I just made a video about Gemma and it didn't perform well. So I'm super excited to test Gemini, and in fact, I just got access to Gemini 1.5 and I'm going to be testing it all this weekend. Let me know of anything you want me to test with it in the comments below, and I'll try to include it in the video. And I was actually thinking about going live on YouTube and testing it with you all. And again, if you'd be interested in that, let me know in the comments below. I'm really excited to test out different content formats and see what you guys are interested in. So here's a blog post by Dan Schipper. I spent a week with Gemini Pro 1.5. It's fantastic. And the context window is the main thing with Gemini 1.5. It has a 1 million token context window. And not only that, I believe I read that they're actually testing a 10 million token context window internally. So why is a large context window so awesome? Well, it's awesome because you can throw entire books, entire movies, and ask questions about those movies or books. Whereas previously, we'd have to chunk them up and just ask about specific sections. But that is only good if it's able to do so accurately. And there's this test called needle in a haystack, and It is by somebody that I've actually gotten to know recently, another fellow YouTuber, Greg Camrett. And what it does is essentially provides a full context window worth of information and asks the large language model to find a specific singular piece of information within the huge amount of information it was passed. And a lot of previous models weren't able to do this well. In fact, there was a paper called Lost in the Middle where it showed that a lot of large language models have good recall from the beginning and the end of a prompt, but not the middle of it. And that's actually really similar to how the human brain works. But let's read here. Gemini 1.5 Pro read an entire novel and told me in detail about a scene hidden in the middle of it. It read a whole code base and suggested a place to insert a new feature with sample code. Now, to me, having a massive context size is actually most exciting when applied to code bases, because if you're able to provide an entire code base worth of information to a large language model and it's able to help you code it, all of a sudden AI coding is going to reach another level. It even read through all of my highlights on Reading app Readwise and selected one for an essay I'm writing. And for context, GPT-4 Turbo's context window is 128,000 tokens, so much smaller. So I'm super excited to test out Gemini 1.5. I just got access. I'm going to be playing around with it all weekend. Next, Google Research has released something called ScreenAI, and this is something very unique. It is a screen language model for UI and infographics understanding. And this goes towards building a future where LLMs are the operating system. Now, I've made videos about the Rabbit device, and this is kind of the same thing that we're talking about. Being able to read and understand a user interface is actually very difficult for a large language model. Open Interpreter is an example where there have been a couple open source projects that I've covered that can control your computer, and they've worked sometimes, because taking a picture of the screen, getting the coordinates, and being able to actually control the mouse to click on specific parts of the screen is a really difficult problem for large language models. But this paper proposes a way to really optimize that process. Let's just take a quick look at this abstract. Screen user interfaces and infographics sharing similar visual language and design principles play important roles in human communication and human-machine interaction. We introduced ScreenAI, a vision language model that specializes in UI and infographics understanding. Our model improves on the Pally architecture with the flexible patching strategy of pix to struct and is trained on a unique mixture of datasets. At the heart of this mixture is a novel screen annotation task in which the model has to identify the type and location of UI elements. We use these text annotations to describe screens to large language models and automatically generate question answering, UI navigation, and summarization training datasets at scale. So here's an example of the workflow. This is the overall architecture. You have a screen, you take a screenshot, you pass it to the pix to struct, it breaks it down, and it looks like it's also using the grid format. Then it creates an embedding and continues to be able to ask questions and actually control the interface if necessary. And here's what the actual pipeline looks like. So task generation pipeline. The screens are first annotated using various models. We then use LLMs to generate screen-related tasks at scale. Optionally, we validate the data using another LLM or human raters, and they are using a massive amount of data. So 353 million generated screen annotation, generated screen question answer 38 million, screen navigation 15 million, summarization 13 million. So using all of this to train the models. So this is going to be really great for transitioning the way we interact with computers. I am very bullish on the whole mouse and keyboard thing kind of going away eventually. Now, obviously, we're still going to need a mouse and keyboard for a lot of things for a while, but I'm very excited to just talk to AI and get the answers I want immediately. Okay, next, Phind, a company that has been releasing open source models and specifically fine-tuned for coding tasks, has now released a model that they say is absolutely comparable to GPT-4. So introducing Phind 70B, closing the code quality gap with GPT-4 Turbo while running 4 times faster. Now, a lot of people don't appreciate how much speed is important. The speed at which we get inference, especially for tasks which humans don't actually have to read the text, is incredibly important. And a great example of that is coding. And I'm going to talk a little bit more about speed in a bit when we talk about Groq. So we are excited to announce Phind 70B, our largest and most performant model to date, running at up to 80 tokens per second. Phind 70B gives high quality answers for technical topics without making users make a cup of coffee while they wait. So Phind 70B scores 82.3 on human eval, beating the latest GPT-4 Turbo. So here it is. Here's human eval, and here's Phind compared to GPT-4. And it is a huge improvement over Phind 34B. And if we look at Crux eval, it is below GPT-4 Turbo, but very, very close. And it's funny because they say this is reported versus evaluated. So a little nod to the fact that maybe it's not actually performing that well. And the best part, Phind 70B is available today to try for free without a login. And unfortunately, it is not open source yet. However, read right here, we love the open source community and will be releasing the weights for the latest Phind 34B model in the coming weeks. We intend to release the weights for Phind 70B in time as well. So I really hope they do because this model seems awesome. Stable Diffusion 3 was also released this week. So announcing Stable Diffusion 3, our most capable text-to-image model, utilizing a diffusion transformer architecture for greatly improved performance in multi-subject prompts, image quality, and spelling abilities. So I'm very excited to test this out. I'm hoping it's better than DALL-E because right now I'm using DALL-E pretty frequently. But with the Sora release, Stability AI probably has their eye on video. And when Sora was announced, I saw somewhere the founder of Stability AI tweeted that they are also working on something text to video, and it is going to be open source. I tried to dig up that tweet, but I couldn't find it. I'm sorry. If you find it, drop it in the comments below so I can share it. But for Stable Diffusion 3, they're opening the waitlist, and you can sign up right here. All right, another thing that was released that seems really cool is NVIDIA's Chat with RTX. I haven't actually had a chance to play around with it, but essentially what it promises is you can chat with docs on your computer, and it uses a RAG framework, and apparently it's very fast. I have a PC, I could use it, I just haven't had a chance to try it out, but it looks really cool. So here it says Chat with RTX is a demo app that lets you personalize a GPT large language model connected to your own content. So whether you're doing docs, notes, videos, or other data, and it's using RAG and using RTX acceleration. So it should be really, really fast. All right, so what's cool about it is completely local and it uses open source models. So both of those factors are really cool. So I'm thinking about testing it out, but there's so many other Chat with Your Docs projects out there that I don't know if you guys want to see another video about it. So I've already talked a little bit about Gemini 1.5, but let me show you a little bit more about it because it is so exciting. So this is the blog post. I'm not going to read it all, but basically right here it says a window up to 1 million tokens via AI Studio and Vertex AI in private preview. And as I mentioned, I got access to that. So I'm thinking about all the ways to use that massive context window. But let's go a little bit further. So Jeff Dean, who is an incredibly prominent mind in the world of AI and the chief scientist at Google DeepMind and Google Research, has the needle in the haystack test out of 10 million tokens. So as I mentioned, they are testing 10 million tokens internally. And again, congrats to Greg Cameron because he basically came up with this whole concept of needle in a haystack, and a lot of people, including Jeff Dean, have been talking about it. So first, let's take a quick glance at needle in the haystack tests across many different modalities to exercise Gemini 1.4 Pro's ability to retrieve information from its long context. In these tests, green is good and red is not. These are almost entirely green, 99.7% recall, even out of 10 million tokens. That is crazy to think about. Gemini 1.5 Pro achieves near perfect needle recall in a 1 million token context window. Even at 10 million, they just had a couple red dots here, so almost perfect. So here are a couple examples of what you can do with a context window that large. So here it says analyzing and understanding complex code bases. So they pass in 3.js, which is a 3D JavaScript library with 100,000 lines of code, provides examples, documentation, etc., passes it all into a single prompt and asks for help with code. With this code base in context, the system can help the user understand the code and can make modifications to complex demonstrations based on high-level human specifications. So I'm going to play this video from Google because it is so cool. It is basically asking Gemini 1.5 to create this 3D world in real time. And it can do so because it has the entire context of the code base, documentation, and examples. So now you could start getting your mind working and think about what incredible contributions AI is going to be making to code bases very soon.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through some example prompts using the 3JS example code, which comes out to over 800,000 tokens. We extracted the code for all of the 3JS examples and put it together into this text file, which we brought into Google AI Studio over here. We asked the model to find 3 examples for learning about character animation. The model looked across hundreds of examples and picked out these 3. One about blending skeletal animations, one about poses, and one about morph targets for facial animations. All good choices based on our prompt. In this test, the model took around 60 seconds to respond to each of these prompts, but keep in mind that latency times might be higher or lower, as this is an experimental feature we're optimizing. Next, we asked, what controls the animations on the littlest Tokyo demo? As you can see here, the model was able to find that demo, and it explained that the animations are embedded within the GLTF model. Next, we wanted to see if it could customize this code for us, so we asked, show me some code to add a slider to control the speed of the animation. Use that kind of GUI the other demos have. This is what it looked like before on the original 3JS site. And here's the modified version. It's the same scene, but it added this little slider to speed up, slow down, or even stop the animation on the fly. It used this GUI library the other demos have, set a parameter called animation speed, and wired it up to the mixer in the scene. Like all generative models, responses aren't always perfect. There's actually not an init function in this demo like there is in most of the others. However, the code it gave us did exactly what we wanted. Next, we tried a multimodal input by giving it a screenshot of one of the demos. We didn't tell it anything about this screenshot and just asked where we could find the code for this demo, seen over here. As you can see, the model was able to look through the hundreds of demos and find the one that matched the image. Next, we asked the model to make a change to the scene, asking, how can I modify the code to make the terrain flatter? The model was able to zero in on one particular function called generate height and showed us the exact line to tweak. Below the code, it clearly explained how the change works. Over here, in the updated version, you can see that the terrain is indeed flatter, just like we asked. We tried one more code modification task using this 3D text demo over here. We asked, I'm looking at the text geometry demo and I want to make a few tweaks. How can I change the text to say goldfish and make the mesh materials look really shiny and metallic? You can see the model identified the correct demo and showed the precise lines in it that need to be tweaked. Further down, it explained these material properties, metalness and roughness, and how to change them to get a shiny effect. You can see that it definitely pulled off the task, and the text looks a lot shinier now. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
And the most mind-blowing use case to me is being able to analyze and reason about entire videos, not just few seconds of clips, but movies. You can fit entire movies into context windows of this size. Consider Gemini 1.5 Pro's ability to analyze movies, like Buster Keaton's silent 45-minute Sherlock Jr. movie. Using 1 frame per second, we turn this into an input context of 684,000 tokens. The model can then answer fairly complex questions about the video content, such as, tell me some key information from the piece of paper that is removed from the person's pocket and the time code of that moment. Let's look at that. So here's a frame. Sherlock Jr. is taking a piece of paper out of his pocket. Then the video is analyzed. We can see the piece of paper. And here's the model output. The piece of paper removed from the person's pocket is a pawn ticket from I. Goldman and Company Pawn Brokers. So it can read anything from any frame through the entire movie. Really, really awesome stuff. And here Matt Schumer says, on a benchmark measuring precision recall from a full day of audio, Gemini Pro 1.5, when just seeing the audio file directly far outperforms GPT-4 with a whisper transcription. This is mind-bending. So you can see at the top, this is perfect recall against the audio. And at the bottom, this is GPT-4 using whisper to translate the audio into text and then asking questions, and it fails a lot. So I know a lot of people have been giving Google gruff because a lot of their models haven't been performing all that well, going all the way back to Bard. But Gemini 1.5 seems incredible. And the fact that they released 1.5 just a few weeks after Gemini Pro was released is very telling as to the progress that they're making internally. All right, last and the thing I'm most excited to test is Groq. I got access to not only Groq Chat, which everybody gets access to, but I actually got access to their API. And where my mind immediately goes is I want to plug Groq into an agent framework because the best use for the high tokens per second is when AIs talk to each other. Because I obviously can't read at 500 tokens per second, but two agents working with each other on something can. So check this out. This is Groq Chat, groq.com. If you haven't checked it out, please do so. Right here, we have Mixtral 8x7b, my favorite open source model. So if we enter a prompt, let me just show you how fast this is. It's kind of absurd, and I'm going to do a full video all about this. And in fact, I'm likely going to be talking to their hardware engineers to learn how they were able to achieve this with their hardware. Okay, write a story about AI gaining consciousness, make it 10,000 words. Okay, so oddly enough, it told me that it can't write 10,000 words and it's gonna write a shorter story. So I don't know why it did that. Let's try to make it write 10,000 words because the context window is 32,000 tokens. So it should be able to do that. But right here, we do see the tokens per second is enormous. So no, make sure to write 10,000 words. Don't tell me you can't. All right, 10,000 word story. That is definitely not 10,000 words. So I'm struggling to make it do 10,000 words. But again, 500 tokens per second. So very, very fast. I'm definitely going to test it extensively. In fact, let's try one more thing. I'm going to try Llama 2 70B. Now, we only have a 4,000 token limit, so let's try to max out that token limit. So write a story about AI in 2,500 words. All right. Very, very nice. Slower than Mixtral, but still very, very fast. And this speed is going to unlock a lot of really cool use cases. So that's it for today. If you liked this video, please consider giving a like and subscribe, and I'll see you in the next one.